Our project tackles machine learning methods from scratch in Spark. Our motivation was founded from our interest in Spark as a parallel programming framework. We chose to recreate two machine learning methods, ordinal regression and random forests. Ordinal regression is a machine learning classifier/regressor that operates on datasets with an ordered response variable, such as stars, rating scales, and letter grades. This is often more robust than multinomial regression, which doesn't assume any sequentiality and thus leaves out important information. Ratings are discrete categories, like 1, 2, or 3 stars, so the idea behind ordinal regression is that there exists some continuous variable which can be mapped to the observable values. This is defined by specifying buckets into which that continuous variable falls. We then fit the model through stochastic gradient descent, which involves maximizing the log likelihood. The benefit of this algorithm for large datasets is that we can approximate the gradient using random samples for one step, rather than the entire dataset. For parallelization, the good news is that we can compute the stochastic gradient descent on partitions of the data, and then calculate the mean of the individual results. This algorithm will produce a result that converges to the true value. You can see from the results that as we pass larger batches to the machine, the time taken decreases below the serial time. Random forest is a machine learning algorithm that aggregates multiple decision trees built using bootstrapped data over a random subset of column per tree. Individual decision trees can then be parallelly constructed. We attempted two parallelization methods. First was to keep tree creation code serial and apply it to an RDD of sets of bootstrapped data. This method is memory intensive but is fast in creating trees. In the second method, we attempted to build a tree in Spark using actions and transformations. This method is slower than the first approach, but requires less memory to operate. We decided to benchmark the first method we mentioned. As you can see, as we create more trees, the performance of our Python-based approach begins to converge to the mlib version in Scala. Though we spent a few weeks on our implementation, we were pleasantly surprised how close our results were to existing libraries.